All right, section 2.1, there was a lot of question marks on the homework, so let's start going through them. Number 4, it said solve this. It's an inequality which you solve just like equalities, except if you multiply or divide by a negative. So if I want to solve for the x, I subtract 3 from both sides. And I get negative 2x greater than 2. Divide by negative 2. And I'm dividing. Adding or subtracting doesn't do anything to the sign, but multiplying or dividing by a negative flips this, and so I'm dividing by a negative. So I get x and I get negative 1, and I have to flip it. And so to show that on a graph, it would be negative 1 and not negative 1, but everything less than negative 1. Or if you wanted to use the interval notation type on a graph, it's below negative 1, not including. Okay. 5. Rationalize the denominator. It's got a square root plus or minus something, and so we multiply by the conjugate, which is square root of 5 plus 2. And that's all it asks for, but let me show you how that works. So this becomes 3 square root 5 plus 6. The denominator becomes square root of 5 times square root of 5, which is 5. Square root of 5 times a plus 2. Square root of 5 times a negative 2. And negative 2 times 2 is, and the middle term drops out so that we get no radicals, no square roots in the denominator, and we end up with 3 square roots of 5 plus 6, all divided by 5 minus 4 is 1. This happens to be just a nice number 1, and 1 will go into both of those, and so we get 3 square roots of 5 plus 6. A quotient is considered rationalized. This was a quotient, two expressions divided, if the denominator contains no square root, cube root, whatever, contains no root signs, whatever root that it is, 2, 3, 4, 5, whatever, so no radicals, those are called. Okay, 7. If it's defined like this, x is the variable that we get to pick, so that's the independent variable. And the response is the y, or the dependent variable. So if f has a domain from 0 to 7 inclusive, and g has a domain of negative 2 to 5 inclusive, then the domain of f and g, well, to do f plus g, we have to be able to figure out what f is of it and g is of it. Now, we only know how to do f from 0 to 7 inclusive. We only know how to do g from minus 2 to 5, but we have to be able to know how to do f and g. And the only one numbers that we know for both of them are from 0. Just take a look at the line. We know from one from 0 to 7, the other one from minus 2 to 5, and so the only ones we know for both of them is from 0 to 5 inclusive. We know how to do 5 in both of them, we know how to do 0 in both of them, and we know the numbers between those for both of them. So that's the domain of the sum of the functions. If the domain of, what's the domain of f divided by g? Well, first of all, g can't be equal to 0, because that'd be division by 0. So any x element that causes the G to be 0, we have to throw out. And it has to be in the domain of both F and G. You have to know how to do F of it, of that domain element. You have to know how to do G of it, just like we had to pick numbers in the domain where they intersect. We have to do the intersection of F and G and throw out if G equals 0, we have to throw that out. And that's number 9.